Okay, this is another hypothesis testing example. This time we are using a t-distribution. This problem is from the textbook, page 309, problem 12. And the problem is we are going to try a new method, a new manufacturing method. And the old method, or the current one, takes 42.3 minutes to assemble. This is a manufacturing process. And the new method, trying the new method, we take a sample of 24 units, and those 24 have a mean of 40.6 minutes, right? And the sample standard deviation is 2.7. So all of this is related to the sample, right? Sample size is 24. The mean of the sample is 40.6, and the sample standard deviation is 2.7. This fact of having the sample standard deviation instead of the population takes us to the t-distribution, and the level of significance, or alpha, is going to be 0.10. And the question is, or the claim is, that the new method is faster, and this is what we had to do to test it. We are going to do a hypothesis test using a t-distribution. Now, the first thing we do is transcribe all the data, or basically label the data. Now, if you notice, the sample size was 24. The mean of the sample, x bar, is 40.6. And the standard deviation of the sample, s, was, or is, 2.7. And this will be in minutes, and the mean is also in minutes. The claim is basically that the new method is faster, right? So the new method is faster. And we are testing this hypothesis using an alpha of 0.10, basically 10%. This is typically called the significance level. Just like in any other hypothesis testing, we are going to do this in 3 steps. Now, the first step will be to write the hypothesis. You have a null hypothesis, you have an alternative hypothesis. Now, the null hypothesis is always about equality, about an equation. Now, this is about the mean of the sample. It is also about the mean of the population, right? So this will be, the mean is equal, and in this case, the question is related to 42.3 minutes, right? We're trying to find out whether this method is faster than the old one, and the old one, remember, was 42.3 minutes. So this will be 42.3. And the alternative is related to this one, but notice the test is whether this is faster. Faster means that the mean is less than 42.3 minutes, right? This is minutes of assembly. So being faster means that it takes less time, right? So the null will be the mean is equal. The alternative is that the mean is less than 42.3, which means that the new method will be faster, right? At least that's the hypothesis. Number 2, we are going to do the graph. And notice the fact that we have S rather than sigma makes this graph a t-distribution. And the fact that this alternative hypothesis is less than implies that you have one tail on the left side, right? Less than implies on the left, more than, if we had a more than, you will have a tail on the right hand side. Now, the next step, in this step number 2, will be to find the cutoff, or the critical value here. Now, this is a t-distribution, so this is a t-value. The critical value in this case is a t value. Now, the way we find this one is to look at the t-distribution table. Notice you have 24 in the sample. That means you have 23 degrees of freedom, and 23 degrees of freedom will take you to the t value. And notice that this area right here is 0.10. So this area right here in this tail is 0.10. So we are going to find this value using the t-table with 23 degrees of freedom. All right, so let's go and take a look at the t-table. The t-table will be this one. Well, I really doubt that you are able to see this table, but you will have 23 degrees of freedom, and notice this is 0.1 in one tail. So we find the t value with 23 degrees of freedom. It's around here, and 0.1 in one tail. All right, 0.1 in one tail, 23 degrees of freedom. That amounts to 1.319. So it'll be 1.319. Make sure that you verify that this is indeed correct, right? So it's 23 degrees of freedom, 0.1 in one tail. That gives you 1.319. And notice that this is on the left side of the distribution, so this has to be negative. So this is a negative value, negative minus 1.319. This is the cutoff for the hypotheses. In the center, you will have the null hypothesis, and on the left side, on the far left, you will have the alternative hypothesis. And the cutoff will be the critical value of minus 1.319. Now the next step is we need to find where the sample is, and we find where the sample is by using a formula. Now the corresponding formula is a t-distribution, right? So it's a t formula. The t formula looks like x bar minus mu, and instead of sigma, we're using s, and you divide that by the square root of the sample size. And we basically have all that we need. We have x bar, which is 40.6. We have mu. We are assuming mu is 42.3. S happens to be 2.7, and then n, of course, there will be the sample size of 24. And you can consider that to be step number 3. All right, so this will be step number 3. And all right, so I'm going to find where the sample is. I'm going to continue with step number 3 here, and t is equals x bar minus mu, so it will be 40.6 minus the mean 42.3 minus the mu 42.3, and then you divide that by s 2.7 divided by the square root of n, which is the square root of 24, and this value will be a negative value, and this tells us where the sample is. Now the next step, of course, will be to find this number t using the calculator, and you can do that in 2 steps. So 40.6 minus 42.3, I get minus 1.7. This on top will be minus 1.7, and to find this number on the bottom, you divide 2.7 by the square root of 24, and I get 0.55. So this is 0.55, and you don't have to do 2 steps. You can do that in 1 step, and at the end you get 1.7 divided by 0.55, and you get minus 30.1 basically. And make sure that you verify this number, minus 3.1, just to be on the safe side. Let me find the number again. 40.6 minus 42.3 and then you divide that by 2.7 divided by the square root of 24, and this will be minus 3.1. Now, the next step, you have to find what the sample is, and you basically compare this t, which is the sample statistics, with the cutoff. Now, the center will be here, so it will be basically 0, minus 1, minus 1.3, minus 2, minus 3. You can see that the sample is to the left of the critical value, and that implies that we had to accept the alternative. See, this is the null area, this is the alternative. Now the sample indicates the t statistic, this is the sample t, indicates that we are on the alternative area. This is the null in the center, this on the far left is the alternative area. And what that means, that we had to accept the alternative, right? Because the sample is in the alternative area. So, well, instead of saying accept the alternative, I'm going to phrase this as reject the null, which is technically the same. Rejecting the null means that you accept the alternative, or accepting the alternative means that you reject the null. And notice, rejecting the null, you are accepting this, and this one is telling you that the mean is less than 42.3, and that implies that the new method is faster. All right, so this will be the conclusion in context. The new method is faster. And that is basically the end of this problem. And I will continue with another example related to the percentage of the population, right, to the population proportion. All right.